the ambiguous case. This is where I have two sides in an angle, but the side is not included between the angles. So I have an angle and a side and a side. And remember, this little tick matches that one. That means that AB is the same as PQ, and it means that BC is the same as QR. So this is an angle that's the same, a side and a side. Those two triangles are congruent. But the problem is, this angle right here, angle Q and angle B, it's not locked in. This side QR could slide over this way. And look, now they're not the same triangle, but I still have angle side side. So these two triangles, and that's why when I have this, I got to be careful because I might have two triangles instead of just one. So what I need to look at is this angle right here. When I solve for this angle, because see what I'm going to have, let me just put in some numbers here. I have like 30 and 7 and 6, okay? I could do sine of 30 over 7 equals sine of C over 6. And then when I put that in my calculator, I have to do inverse sine, don't I? Well, remember, sine is positive here and here. My calculator's only going to give me this angle. But it could be over here because the angle in a triangle could go up to 180. So what I need to do is figure out if this angle C, if it could be obtuse, because my calculator will only give me this acute angle, this one here. It won't give me the obtuse one. So I need to look at the picture and figure out for myself if it could be obtuse. And what we're going to use is looking at this. I have a side 7. So could you tell me what angle X is? Not the measure, but is it going to be bigger or less than 30? Look at this triangle. Is X going to be bigger than 30 or less than 30? It has to be less than 30 because 6 is shorter than 7. So that right there would tell me I only have one triangle because this angle could not be. It can't be obtuse, okay? So this is what your book gives you to look at. And then I'll show you another way to do it, and you can decide if you want to do this way. So we draw our triangle just like I had. We have the angle here and then a side and a side. So if A is greater than B, then that means I only have one solution. So whether my triangle looks like this or like this, if A is bigger than B, this can't be obtuse because this angle will be smaller than A. If A is greater than B, then that means the measure of angle A is greater than the measure of angle B. And I'm trying to find this angle here, and so that would be angle B. So I know it can't be obtuse because it's less than this one. And there can only be one obtuse angle in a triangle. So we're just looking at these two sides, okay? Now if A is less than B, so if this side is shorter, then this angle could be obtuse, or it could be right, or it could be acute. So this is how you're going to tell. You're going to take H and find the height. You're going to find the height of your triangle and do B sine A, just like we did at the beginning. See, because if I have this triangle here, sine A would equal H over B, wouldn't it? So H equals B sine A. So you take the side they give you that's not opposite the angle they give you and times it by sine of A. And that's your height. Now you're going to compare your height to the other side, the side that they gave you. So if the height is bigger than A, well, that means, see, here's my height. If the height is longer, this will never, it's too short, it will never touch the other side, so it can't be. If the height equals A, like this, then there's one triangle and it's going to be a right triangle. The other thing that can happen is the height. So we already know it's less than B because that's how we got to this point. But if A is bigger than the height, it's a hypotenuse, and that's when I have two triangles, okay? And A is always the side given with the angle. So that's how the book shows you how to do it. And you can follow their examples, but this is very confusing because A isn't always side A. It's always the one that is opposite the angle that they give you. So let me show you how I try and do it, and then you can decide for yourself. So this is just a shortcut, and you'll be able to use this on the test. If A is greater than B, let me show you what this looks like. So I have A and B. So if this A is bigger than that one, then that means I only have one triangle because this angle here cannot be obtuse. If this one is bigger, then B has to be smaller than A, doesn't it? So it can't be obtuse. If A is less than B, I solve for H. If A equals H, I have one right triangle. If A is greater than H, that's when I have two triangles. And if A is less than H, then I have no solution. So when we're doing this side angle, side angle, these are the three answers that I can get if this happens, okay?